Okay, everyone, hello, welcome. So my name's Richard Bradshaw. I am actually really excited to be here. So I have done over 100, probably more than probably 100, 150, I don't know anymore, talks at testing conferences, but I've only ever spoken at a developer conference twice. I always get rejected. It's really sad. So, because I'm here, and the reason I came is because I was hoping to talk to more developers, can you just quickly put up your hands if you're not a tester or a QA or an Esther or whatever job title? Amazing. Right, so I am a quality engineer by trade. I change my job title depending on what's paying the most at the time. So I can be an SDET, or I could be an automation engineer, or I could be a quality engineer. I could be a testing coach or a quality coach. Doesn't really matter, whichever one's the current flavor of the month. But I've been in testing slash QA, QE for about, I think this is my 15th year in that space. So I want to talk to you about trimming your automated tests. So this is going to be a talk about like how we can basically build like smarter, more intelligent, targeted automated tests as opposed to potentially always going top down. So the projector has a few issues, we've been told. So apparently this guy's first day on the job, so we're blaming him. So why do we have automated tests is where I thought I would start. So automated tests, in my definition, they exist to confirm that there hasn't been any changes. When we see system behavior that we like, and it's doing what we expected, and it makes us happy, and we feel like we've done a good job, we want to codify something that tells us if that ever changes. Because if it changes, it's going to change the behavior of the team. We might have to fix the issue. We might not test something because we've not been aware of it. So for me, they're very much confirmation. We've done some sort of human manual exploration type of testing, and that could literally be running the function and getting the number you wanted, or it could be exploring a whole UI end to end, right? But we've triggered the system and seen it do something we like, and then we've gone, I like that behavior, I want to know if that behavior ever changes. So that in my mind, that's why we automate it, and then in turn, that usually brings faster feedback, it's much quicker, but obviously comes at a cost of maintenance, and we lose some of that human serendipity that we get when we tend to tinker with code or look at the product as a whole. Clicker doesn't want to work anymore. Let's try again. Oh, there we go. So I like to frame my talks around problems that I believe exist. You might disagree, but hopefully we all hopefully don't. But I think too many tests are automated too high up the application stack and too far away from where the risk is actually trying to mitigate it. So I don't just mean UI, but that's an obvious place, right? There's too many UI tests, there's too many end-to-end tests. But even sometimes, I'm not a developer, but I'm quite comfortable coding. We build quite large classes, right? And then we test those things as a whole. And sometimes our tests just generally are a little bit too big. And we need to get better at mitigating the risk. And also, I think too many tests exist now that should be deleted. It sounds people like get scared when you say delete tests, but like we should be deleting tests on a regular basis, not just unit tests, all levels of tests, because sometimes tests just exist because at the time it made sense to have it, but since then we've built new features or we've refactored stuff and we've added in new tests. But we also sometimes need to take some away some of the old tests because they cause us to have long, extended runs. And there's a few reasons why I believe this happens. The plethora of tooling on the UI layer. So if you ever go to a testing conference, pretty much every other tool vendor is trying to sell you some UI tool with AI healing magic powers that can solve all your problems. But they exist and they seem to sell. So people are buying them, so people are using them. Testers generally, anyone who identifies as kind of that role, we tend to be more comfortable on the interface that our customers are using, which tends to be some sort of UI. So they tend to like to test and automate there. There's still I don't know why, but there's still a fixation in our industry on end-to-end testing. And who has more than like 100 end-to-end tests in their products? Yeah, you're all too shy to admit it, because I'll find you, right? But we have this fixation on long end-to-end tests, and that needs to start tweaking. And I think I have opinions on why that happens. I think one of them is poor technical knowledge of the system. A lot of people still view the system as a big black box. There's stuff happens on the UI and then magic happens and we get back a response. We need to start digging a little bit deeper, I feel now, and obviously systems are getting incredibly complex. I've learnt about tools here in the last day and a half that I've never heard of, and I'm like, what's that? And I Google it and it's like, oh, this is used by loads of people. I've never heard of this tool. And there's generally a lack of training in the testing space, and I think even for developers, a lot of your test training around testing seems to be focused on unit testing, which is a very useful thing, but also there is other types we can do now. I'm not trying to upset anyone, but a willingness from some developers to do testing. I was on my last project at the start of January till July. There was half of developers refused to do testing, refused, point blank said no. I don't do testing, I write code. And I was like, I'm asking you to write code. Just the feature you're trying to build is a test. That didn't work. Even the developers that do love writing unit tests, they seem to be reluctant to go anywhere else above that. And obviously there's awesome developers who will happily do anything, which is great. But I also see very poor collaboration in some companies between testers and developers. So we end up seeing a lot of testing that gets repeated. You've written, the developers, I say you because I'm assuming most of the audience is some sort of developer focus, but developers write all these amazing unit tests that the testers never look at, and then they go and do lots of other API or UI tests that are literally testing the same thing. And the risk is completely missing and they should do something different. So I think we need to get better at working with each other. Legacy test suites, anyone still use, well, I'm not going to name tools, that's harsh. But sometimes, we've had test frameworks that have been there for absolute ages. We can't move away from it. It's too expensive. It never gets prioritized, but they cause slowness as well. That's a problem that we all need to deal with. And again, traditional minded test approaches, QA have to sign stuff off. Nothing can go live without a tester looking at it because obviously we're so superior. But there's these approaches that we have that don't really work in the modern way of wanting to ship software. And the challenges that all this causes, which I'm hoping my model kind of solves, is we get slow feedback from our tests, which means slower time to production. Right? I've worked on companies in the last 2-3 years where their pipeline takes nearly 7 hours to run. Right? I've worked on companies where it takes 12 minutes. One of these teams is a lot happier than the other one. I've worked on teams that have ridiculous amount of test brittleness so that @ignore is no longer sniggered at. It's the default behavior. Just ignore that test, move on. But I've worked on teams that really want to get rid of that flakiness. One of the biggest problems in any testing is test data. It becomes a huge pain point. How do you manage all this test data? And that brings about his massive challenge. And then the one we don't see talking about enough in my mind is how long it takes to debug a failing test. Because we want our tests to fail. It's the whole point of kind of having them. They're catching stuff for us. But then if it takes you an hour, 2 hours, half a day to investigate a failure, that's also not ideal either. And as I mentioned, there's a divide between testing efforts. We need to do it more holistically and cohesively. So I created a model called TRIMS. And the TRIMS model is, when I say model, I feel like everyone's like, oh, is it some sort of super AI model? No, it's a pen and paper thing that you can draw. But I want people to start trimming their automated tests. And this model can be used in 2 ways. It can be used to evaluate existing tests, and it can be used as a mental note as you're currently creating tests, which I added a slide for no reason. All right, so the model is TRIMS. Targeted, reliable, informative, maintainable, and speedy. I wanted this to be F for fast, but Trimeth didn't sound as good as a mnemonic, so I ended up with speedy. So what I'm going to do is wait for it to come back, and then we're going to go through the letters. But I can see it, so it's all right. But T is targeted. So, and when I say targeted to a specific risk. Risk is the really important word that we don't talk about often enough. And automated on the lowest layer that your testability allows. So the 3 keywords are risk. I'm a tester SaaS QA, and I don't say this word often enough, right? We very subtly hear the word risk. And I think that's what we're trying to mitigate. We're trying to mitigate risks. The lowest layer, that for me, as I'll show a model in recently, is when you think of your app as a big stack or a linear thing, where's the lowest point that risk shows its face? And we'll look at an example shortly. And then testability is a fancy word for your ability to test. In your teams, every single one of you has a different ability to test. Your product might not be very testable. You don't have dedicated testing resources. Your developers don't want to write tests. You might have deployment issues. Everyone has different constraints, and that's what testability is. So I wanted to talk about targeted and bring up these test automation triangles. I call them triangles because they're not pyramids. It really upsets me that it got called a pyramid. It's not a pyramid, it's a triangle. But these all came around to help people think about how to target their tests, but they don't really tell you how. Yet a lot of teams use this as their strategy. They use it as to say, well, our testing can't be very good. We have too many tests here and too many tests there, which kind of isn't true. Like, this should be used as an heuristic. But we have a lot of triangles and people turn them upside down and put ice cream on them and all sorts. And then a lot of people didn't understand the triangles, so we started adding labels to it and percentages just to help people get by. And then we started adding tools to it because people didn't know what tool to use. So there's lots of these out there, but they don't really help you actually design your test. But it is a useful model to critique your test and see, actually, do I have too many on a certain layer? And then ask the question, is that a problem? It might not be a problem, because if all you can do is test on the UI because of the way your product is, you're doing the best job you can do. Yet this model will tell you that you're not doing a great job. So try and use it as heuristic. This is what I like to try and do. This is a really simplified model, by the way. I really wanted to make that clear and make sure I said this. So what I like to do is try and model my system. And when I say model it, you could have tools that generate this for you. I'm sure there's lots of tools out there. But I like to think of the layers that exist in my app. So this is a very simple website. Obviously, you lot probably work on even more complicated things. So you would have a lot more layers and lanes. You could have event queues. You could have multiple DBs, third parties. There could be an AI box in the corner doing some magic, right? You could have lots of stuff going on your system. But if we model it out like this and we look at the behaviors that we're trying to automate, we can basically follow what's happening in our system. So observability space obviously has a lot of this with tracing, but I'm trying to view it from a testing mindset. What happens when I click on this? This is a login website, really simple. But when I click the page, React goes, oh, hello, you would like to build the login page? I know how to do that for you. I'll build that for you. We fill it in and we click go, and then the React framework might go, oh, you want to send an API? Cool. Ends up in our API queue. This is a terrible app that I written, by the way, so I couldn't be bothered coding a DB, so I hard-coded the credentials, which is why it doesn't go down to the DB layer. But it was just for testing, training purposes. But it goes into the app layer. That does a hash check on the password and decides if it's OK. If it's OK, it'll make you a token. Goes back to the API and says, I'm going to send this back for you, converts it to JSON, etc. React goes, oh, look, your system's told me you're a nice person. I'm going to let you in, and I'm going to redirect you to the room. Now, when we come to things like login pages, we start to think of how, let's test I can log in. Let's test I can't log in. Let's test if I don't put a password in. But those risks are happening at lots of different points in our system, yet we tend to stick to the UI to do those things, whereas I would like to start automating down the stack. So we can think of lots of different risks. Does the form render properly, right? Does it actually render the right fields and the right HTML, etc.? When I interact with it, does it let me? Does it send the right data to the API? Does the API talk to the right code, what the right classes, whatever's doing the check-in? And then eventually, does React, move me on when I get the flag back? So I can start to think of lots of different risks, and I've missed one. Does the page even look correct? That's another thing that we see in our space. We do a lot of end-to-end tests, and we think we're testing like the user. We're not. The user, we're not checking the page looks correct unless you're doing visual testing. Often you're just checking there's text on the screen. I wrote a website for my blog, put my training in the middle of it, next date, big red button, left a bracket off my CSS file, deployed it, all my tests pass. Because the next training session was in the middle of the page. It was still there, but it was obviously not all styled nicely. So I got my risk wrong. But if we model like this and we use the targeted approach, we can start to put actors into the mix. So when we think of a testing framework, we're usually pretending to be someone. So when we do component testing, we're pretending to be React, for example, perhaps, or some sort of JS framework. If we're playing on the UI, we're pretending to be a user interacting with a browser. If you're doing unit testing, you're pretending to be whatever framework or coding language you're using. So we always have some sort of actor, and we can identify who that actor is, and then we can go and find an appropriate tool. And then we can start to use this model to work out which bits of the system we don't need. So if I'm testing my component, I don't need all this bit of the system. So can I mock it? Can I fake it? Can I stub it? And I can easily see what it is I'm trying to have to mock, which will give me an idea of how I'm going to go about doing that. And then the same at the top. I don't need to care about the bit above because that's not my risk. My risk is, does that component do what it's meant to do? I don't need the rest of the system, but I know that it might try and make a call, so I'll probably have to catch that and stub it out, or I might have to point it somewhere else because I can see that there's a connection going on with the model. Another example, if I'm going to do a UI test, again, trying to break the end-to-end cycle and make them smaller, I can mock all the API calls, right? I can capture the requests, give back dummy data, and basically make my test nice and small and targeted to the risk, which is, does the UI look correct? Not, does the UI look correct? Send all the API, go to the database, come back up. I don't need that. It's not my concern, excuse me, for this test. And then I mentioned testability, which is a really important factor. So we know we should automate here, but no one has the skills. No one has the time. The product's not designed to be able to be testable there. Perhaps it's a third-party tool. We can't get into it. There's loads of reasons why. So we have to go up to the next layer. Can we test it on that layer? Yes, we can. No, we can't. Go to the next layer until we eventually end up on a layer that we can test it on. And that shouldn't be frowned upon, right? This is why sometimes our pyramid may look like a T or a cross, but we're still doing the best we can do because of the restrictions and constraints that our testability provides. So this is like justifying your thinking. And I wanted to be clear that I don't draw these out on paper. So I basically created this technique to teach other people how to do it because it means you can collaborate and point to it and draw on it. And one of the things I love about drawing these, if you're in the office ever at all, draw one and put it on the wall somewhere and come back the next day, someone will have scribbled all over it. It doesn't work that way, works this way, it doesn't work that way, this is how it works. And people will start telling you how the system works. And it's great because you find out lots of things. So when I think of targeted, I think of risk. I think of who's the actor. I think of the layers of the system. I call them layers. Some people call them seams. But I want to work out these layers, and I want to work out where I can get my grubby little testing fingers in and start automating on these different layers. And obviously, testability is going to impact what you can and can't do. You obviously, in my mind, I like to think I can do every type of testing, but sometimes there's no time, there's no budget, the company only wants me to do a certain thing, so I'm going to have to keep going in that way. But if I have a model, I can then use that to explain, look, we're going to do this, and I'm okay to do it now, but this is going to come back and hurt us at some point if we don't start addressing it. All right, so reliable. To maximize their value, tests need to avoid intentional flakiness. So I used to just have, this is flaky, isn't it? That's good timing. And again, we're going to put this on the video. It's amazing. Oh, never mind. And the final bit says we need it to be deterministic. Work. Thank you. Nearly. Right. But yeah, we need them to avoid intentional flakiness. So I used to just say flakiness, and I can't remember, I should save the link and put it on the page, but Meta did a really good white paper where they spent millions of pounds building a tool to detect flakiness, pull the tests out, try and fix them, put them back into the pipe, and they just canned it. They just deleted it all like one day and said, this is not working. We can't avoid it. The complexities of our systems these days means flakiness is just inevitable. It's going to happen. So let's try and design smaller targeted tests to reduce the risk of it happening. But it is still going to happen and we can't avoid it. The systems are just too vast. And like every little tiny thing can cause it. It could be your code, it could be the network conditions, it could be anything. Cloudflare could go down, right? There's loads of things that you can't control. So testing your tests is a way of getting reliable. I'm not going to name them, but about 3-4 years ago, basically someone said this to me and it stuck with me. It's like, you want me to test my tests? It's like, it's taken me so much effort and energy to even write the tests. I'm like, yeah, you should test your tests. And the way we can test our tests and why we need to do it is because we need them to be reliable. So for me, I like to run the test a couple of times, make sure it is actually doing what I intended, especially the higher up the stack I go. If I get towards the API, UI end-to-end level, I want to make sure they're actually capable of running. Reverse your assertions. Who's written a test that can never fail? Come on, be brave. Yeah, we've all written them, right? I've literally coded the words assert true equals true, and didn't pass in because I was built. Yeah, I'm not making excuses. I'm not gonna embarrass myself. But yeah, I left it in there. I committed it. It stayed there. It stayed there for about 2 years. No one noticed. So I like to obviously avoid that now by switching my assertions around, seeing if the test can actually fail. And it's also a good way of knowing if you designed a good oracle. So if you don't familiar with the word oracle, a good assertion, the thing that you observed your system do that you decided is how I'm going to see if there's a problem here. So people at various skills of people have varying skills of doing that, but what are we choosing to decide that the system's behaving correctly? And then are we designing a good assertion for that? And obviously, back to my models, this was an example of a more complex flow, but you can see we're going up and down. I think it's 24, 25 times, I'm not sure. But every single dot, every single crossover of a seam could introduce an element of flakiness. So as our tests get bigger, we're kind of accepting that this is going to potentially be a problem. And the fun thing about these, if you turn it upside down, it looks like a pyramid. So you can see that you start to get targeted tests. So that's reliable, right? Deterministic, and we want to reduce our mean time to feedback. So mean time to feedback is the language I like to use. Regardless of if you have testers or anyone in your company like doing the testing / wearing that hat, when your build passes, if you don't have like continuous deployment, or even if you do, someone coded a rule that decides if it's good enough. So sometimes it's someone's job and they go, you know what, it's green. Nice. And then sometimes, and people like me go, green? Really? Like, I'm sure Dave worked on that feature. There's no way that build's green. So the sooner I get the results, the sooner I can put it into context and make a decision on whether that's suitable for being pushed live or going to the next stage or whatever it is. And obviously, the smaller our tests are, the easier that is to do. Informative. Let's check time. Yeah, passing and failing tests need to provide as much information as possible to aid exploration. So when a test fails, we obviously, we want to learn why it's failed. There's a reason to look. But also when tests pass, maybe it's probably more of what a tester might do, but we have ideas of other types of tests that we want to do, and we might look at the existing tests to see actually, is that being covered already? Is that idea being covered? Or if I'm thinking of writing some more higher up the stack tests, I might look at your unit tests and go, actually, do you know what? I think that's covered there. But in order to do that, they need to be well named, they need to be clear what they're doing, and it needs to be quite readable. But they always aid exploration. It is always a part of the journey. Get the information, digest it, put it into context, work with it on the next step. And it's not just failing, it's passing too. Ziggy, wherever he is, Ziggy, the guy who invited me, he told me to add code to this, and I thought, you know what? They're all going to judge me, aren't they? They're all going to read my code and judge my coding skills. So I put a little bit in, but not a lot. But there's certain words that we see in the way we name tests. So people use the word should. And I'm like, well, it either does or it doesn't. If it should work, you're literally just telling me that your test is flaky in the first place, right? So we've got certain words just don't make sense to use. So should is one of them. I'd rather be more dissertive, returns, returns a certain exception, right? As opposed to should return an exception, right? You see, you should have coded it so you know it's going to. So get rid of the word should. Can, valid, invalid, good, bad, anything along that. It's like, why are you not telling me what you've determined as being good or bad? Just declare it for me. Just say what it is. We want to be really declarative and specific. And then the word test, right? Most of the tools don't need it anymore. So why are we sticking the word test at the end of our tests? It's in a test file called tests. And then we put the word test at the end of it. Or the class is called test. So then we put the word at the end of the test. So there's too many tests. So yeah, have a think about how you're naming them. Here's an example. I actually stole this from tests, but there's one that says should throw an exception. It's like, really, just say it throws an exception. The word should is not adding any value to this test at all. It's just making it even longer than it is. It's too long as it is anyway. And then here's some slightly better examples. I didn't want to put code in because I've tried to make this obvious up here. There's a trillion test frameworks out there, right? And they all look different. They all write things differently. So I just use this one as a good example, but it's bank account. So what is the unit area component of the system that we're kind of focusing on, the actual area? kind of have that at the top. And then a certain behavior that we're doing. So in this instance, it's opening a new account or depositing to an account. And then give the name of the test like declarative. Give it an what are you actually expecting the test to do. And the better they're named, the quicker it is to debug them, understand what's gone wrong, and also understand whether we've got decent coverage, right? Because coverage is a word we all love, right? Every single one of you needs 100% coverage, right? Yeah? No. Coverage is coverage of some model, right? So what is that model? Who's decided what that model is? But when we do decide that, we need to be able to quickly work out if we've covered our tests. But obviously, you can do this in folders. I'm a Ruby on Rails person. Please don't hurt me. I don't know if anyone likes Ruby on Rails, but most people prefer Java and TypeScript and stuff these days. But we have obviously describe and it in the Ruby on Rails kind of testing tools, so you can use them too. But there's many ways to do it, but we kind of want to have this layered naming to our tests because they help the exploration. Test output. I put this emoji to remember me to say something. Probably shouldn't have told you that, but I did. When a test fails, right, this is what every single one of us does. Test fails, pipeline, you get an email, Slack message, whatever it is, you've been notified. If let's say it's an API or a UI test, that TV's gone really weird, but anyway, it will come back. So we all get a UI test, we download the latest of the test, right, and then we click play, and then we stare at it. Come on, I know you're going to fail in a minute, I know you're going to fail, and then Dave goes, hey, Richard, and you're like, oh, for fuck's sake, Dave, right, and then you run it again, and then you're watching it again, I know it's going to be that button there, right, and you're just waiting for it. All that takes time, right? It's fun, but it takes time. We'd rather have the system or the tooling collect as many artifacts as possible. If you're doing a UI test, it's kind of expected now. Video, screenshots, anything, log files, console logs. If you're doing anything in the API space, print out the headers, print out the JSON, give as much information as you possibly can to speed up that investigation when your tests fail, because that takes time. And especially when most of us probably have a life or a day life where, the build's failing. So I could fix that now. Oh, there's a meeting. You come back out of the meeting. Oh, it's lunchtime. I'll go there. And then by the time you do fix it, someone's broken another test and then the pipeline fails again. So, okay, we'll start the process again, right? So the quicker it is, the more likely it is to be done. And again, didn't want to put too many ways. There's a trillion ways to collect artifacts. I'm just saying as a model, think about what you would need to know if this test ever failed, so you can understand the context quicker and fix it quicker. And there's also a really fun meta thing to think about. I actually believe it's very rare that we ever fix a test. I think we basically always make new tests. We just use 99% of the old test, because if the test was still working, it would work, right? So sometimes it's like naming conventions, but often we're actually tweaking the test to be a new test. But that's for another day. So informative, debugging, exploration, and decision-making. Our test influence the way we just go about releasing our software. As I said, if it goes green, sometimes that's happy days. Sometimes we talk about the illusion of green. Is it actually green? Is it actually okay? Are our tests any good? Did Dave write them all? We need to be able to put that into context to decide what to do. And if you're called Dave, I'm really sorry. It's just a common British name. Maintainability, or maintainable. Automated tests are subject to constant change. I always say that, and it's great because if they're not subject to constant change, what are you lot doing? Where's the features coming from? What are you doing? Are we refactoring anything? Like, what's actually happening, right? If you're doing your jobs and we're building new features, these tests should be going, hey, the system doesn't look like that anymore. Someone's added a button over here, or someone's added fields to this API. So they should always be detecting these changes if you've got really good tests in place and nice and targeted. So if that's the case, we need to be able to get them back up and running quite quickly. So again, I'm only covering some high-level examples because there's only so much time. But there's design patterns we can put in play for our tests. Anything on the UI, screenplay pattern, page objects are very common, even though now people don't like them. But the range actor cert, and then the data builder pattern is one of my favorites, because I think data is a massive problem when it comes to tests. So having a data pattern where you can basically create data on the fly and not have to rely on data dumps or feeding data into a database, actually code a system to do it for you. And I use the data builder pattern. It's probably got a different name, but it's essentially build me a user that looks like this with these fields, then go and create it for me by whatever method exists, and then I can use it in my tests. Maintainability, avoid conditionals. I cannot tell you how many tests I've seen that basically say, if the page is slow to load, refresh it. and then wait, see if it's there, and if it's not there, go back and go forward again. And it's like, no, you've got a broken system. Like, stop coding your test to deal with your crap system. Fix your system. Or, having the system come out, if it does this, then do that. If it does this, then do that. Have 2 tests. Don't have one test that has conditional stuff in it. Just make more tests. It's easier. And focus on readability and simplicity is kind of key, but most of you probably know this. And we were talking about this with Michael. Michael, I'm going to call you Michael. It's easier. I can't say it in the German way. But we were talking about this last night. Test code is used to judge the production code, right? But the quality of test code is often pretty damn poor. So, like, why are we using that to go of all the amazing production code that you've written and then got this absolute bag of garbage to test your code? We need to give it the same love, if not more love, to try and keep the standards high, because we need both of them to be really good. So yeah, it's kind of a question for you to take away. Which is more important, your production code or your test code? And if you want to know more about maintainability, Michael is sat at the front row. He has a talk tomorrow at 1 o'clock, and he will go into far more depth than I've got time to on this one. So yeah, think design, think clean code, think good practices. And again, I'm using this mnemonic trims as either when you're doing the work, and as you're doing it, just have trims in the back of your head. Have I written a maintainable test here? Looking at the wrong thing. Speedy, the last one. Creation, execution, and maintenance needs to be as fast as the testability allows to achieve rapid feedback loops. So I think this often gets missed when it comes to automated test. We think of speed and we think of execution. So then what we do there is there was a talk yesterday by Daniel on pipelines, and we start to make the pipeline more sophisticated and as in run these tests first and these tests next and run these in parallel. And then if you've done this, you probably shouldn't own up to this, but I've done this. Then you write something awful in like a Jenkins script that says, on this process, run all the tests that start with A. On this one, run all the ones that start with A to D. On this one, do T to Z, right? Just because you're trying to get the execution down. And that's okay. Execution time is important, but there's also the creation time. How long is it taking to create new tests? Is it easy? Is it quick? Is it a long process? We don't talk about that side of automated testing enough. How long is maintenance taking? How long is it taking to debug tests? How long is it taking to increase the version of your framework? There's lots of things that go in that take time. And the more time we're spending on this, we're not spending time on new features, or we're not spending time on looking at our customers' data. Are they happy? We're not spending that time there. So we need to do it in other places. And again, it is all dependent on your testability. It's a really massive topic if you've not come across the term. Everything, the way you work, impacts your ability to test. And we want to achieve rapid feedback loops. I call them feedback loops, but again, the sooner we get the information, the sooner we can make decisions. And I didn't really have anything else to add, but I just wanted to encourage people to just think beyond the execution when it comes to automated test. Have an exercise back at work with regards to your automation. Which bit of having automated tests is actually taking you the most time? And kind of identify what it is and see if you can improve it, and don't just focus on the execution. And then finally, I wanted to talk about trims as a heuristic. So if you've got existing tests, take the trims mnemonic or the trims model and basically judge your existing tests. Or you can even do this in PRs to basically say, actually, I think this test is not ideal. It could be more targeted. Could you improve this maintainability bit, for example? But I like to score it. I'm stood in front of it, but I like to potentially give scores to them. And I kind of have a rule that anything below 40 basically needs improving. And we should look if we can improve it. We might not be able to, but it's a trigger to go and actually look at it. So yeah, it can be used as a mindset thing. I said I don't draw all this out. It's just in my head as I'm designing and coding my tests. I'm trying to make them as trim as possible. But if you do have existing tests, apply the same mnemonic and start trimming down some of your tests. For example, if you've got a lot of UI tests, can you move them to the component level? Can you move them to the API level? Do you really need 100 end-to-end tests if you've covered all these little pieces? And the way I like to think of it is like a big jigsaw puzzle or a collage. I like to make lots of tiny pieces that make up the whole picture instead of having massive end-to-end huge tests that are just going to cause me a lot of pain. I want to get us all thinking about how we can have more targeted tests. And I think with the developers in the room, my encouragement for you would be to pair with some of your testers if you have them, or your QAs, and try and teach them new ways of testing software, or teach them that, things happen down here, this is where the risks are, and start collaborating a little bit more to have these smaller targeted tests that when they fail, we know exactly what it is. When an end-to-end test fails, it could be a trillion things. When a UI test fails that goes up and down the stack, even if it's not end-to-end, just one page, it could be a trillion things that have gone wrong. And that takes time. Whereas if I had a component test, an API test, lots of unit tests, I know more likely what's actually failed. And it's quicker for me to find them out. So yeah, thank you for listening. I have a YouTube podcast show with my mate Vernon if you like listening to random people chat about testing. I don't have a QR code because I don't know why 2 QR codes on a page really upset me, so I took it away. And I'm on LinkedIn, and yeah, thank you all for listening.